Okay, guys, so we're in our student journal. It's section 5.5. We're on page 145. Some things we're going to be talking about: domain, the domain of functions. I keep talking about that with radicals. Normally, though, our domain is going to be all real numbers. The way that we write all real numbers is negative infinity to infinity. That's how we write that in interval notation. However, unless the function contains an even root or is a rational function. So our domain is all real numbers unless the function contains an even root or is a rational function. So what we mean by that, an even root could be y equals the fourth root of x. That's an even root. What would I say about the domain of that? X has to be greater than or equal to what? 0. Okay, so that would be the domain there. In interval notation, 0 to infinity. That's what we mean by an even root. Rational function, that would be something like this. Rational means fractional. What is it if I have a number divided by x? What is the value that x is not allowed to be? What's the only number we're not allowed to divide by? Okay. 0. So x cannot equal 0. That would be the domain of this. So these are the ways we can write the domain. This is as an inequality. This is as just not equal to. We could write it that way. How would we write the domain in interval notation with this one? Go ahead.
It would be x is less than 0 and x is greater than 0.
Okay, but in interval notation, negative infinity to 0 union 0 to infinity. So this is our domain in interval notation. Our domain is an inequality. Okay, makes sense? For a function with an even root, the value under the radical must be greater than or equal to 0. Right? That's what we just talked about here. Right there. For a rational function, the denominator cannot equal 0 or else the function is undefined. So that's what we're going to be looking at in a little bit, is how do we find the domain of functions that we are given. Now, another thing we're going to be looking at is this composition of functions. So this is when we're given a function. I would like for you to write this down instead of where it says scientific notation. Let's talk about compositions of functions. If f of x equals 4x minus 3 and g of x equals x squared plus 1, find f of g of 2. That's the first thing we're going to do. Find f of g of 2. I'm going to write it down, f of g of 2. On these kind of problems, we always work from the inside out. So first we want to find g of 2. That means in the g function, wherever I see an x, I'm going to replace it with a 2. So g of 2 is going to mean 2 squared plus 1. So what is g of 2? 5. So I know the answer to this right here is 5. So now my problem becomes g of 5. Sorry, f of 5. Because I already replaced the g of 2 with the 5. So to do f of 5, that means in the f function, wherever we have an x, replace it with a 5. What do we get? 17. So that would be the answer for f of g of 2. That answer is 17. Do you think we'll get the same answer if we do g of f of 2? Maybe, maybe not. Kaylee, what do you think I do first? Right, so I plug in 2 into my f function. So f of 2 is going to be 4 times 2 minus 3. So what's that going to be, everyone? 5. So now I'm going to be doing g of 5. All right, so now we're going to do that. We're going to plug in 5 into our g function. So what is 5 squared? Plus 1. So that's 26. And so g of f of 2 is equal to 26. Now, there's another way that these can be written. F of g of 2 could also be written like this. F open dot g of 2. That means the same thing as f of g of 2. This could have been written this way. G of f of 2. So those are equivalent to what we just did. All right, we're going to come back to that in a little bit. But we want to shift gears now and talk about operations. This is just a different way of doing something that we've already done. We have done f of x plus g of x, but we haven't seen it written as f plus g of x. It means the same thing. If you're given this function and it's written like this, all that means is to add the two functions, and they got 6x plus 2. When we see this written, all this is saying is the same thing as that. It just means subtract the two functions. So f of x minus x is 4x minus 2, because we're subtracting this whole quantity. For this one, means what you would think. It means to multiply the two functions. Now look at that. F g of x, that means to multiply. Look back up here though. See how that looks kind of similar? And so does this look kind of similar? But this is called a composition of functions, whereas this is just the product or the multiplication of the two functions. And we'll get that. And then, of course, division works the same way. By the way, what's the domain here on this one? What is it that x would not be allowed to be equal to? Somebody knew. Yeah. Good. X could not equal -2 because we're not allowed to divide by 0, and that would force it to be 0. If I wanted to write it in interval notation, it would be -infinity to -2 union -2 to infinity. That'd be the way I could write the domain in the interval notation. All right, so now we're going to go back to this, and we're going to be talking about the compositions one more time. Remember how f open dot g, that means the same thing as f of g of x. This means the same thing as g of f of x. So here are our functions that were given. F of x equals 5x. G of x equals x plus 2. All right, so we're first going to do f minus g of -4. So what that means is we're going to subtract the two functions and then plug in -4. So I want you to subtract those two. We just did it a second ago up above. What do we get if we subtract those two? Karen?
4x minus 2.
All right, so that's 4x minus 2. And now this is saying to plug in -4. So we're going to have 4 times -4 minus 2. And that's going to be -18. All right, so the next one is -4, and then it's f minus g of x. Well, that means I have to do f minus g, which we just did over here. But what do you think this means? Does this mean I plug it in? It does not. See how right here there's no x, so it's saying replace the x with -4? But on this one it's saying to subtract, don't replace the x, but multiply the function now by -4. And so what do we get on that, Tom? If I distribute that out, what would we get? Tom?
-16x squared.
Just -16x. Just distribute that. See, positive 8. See, we don't include this x. This doesn't, I see what you were thinking. Like you were thinking we had to multiply it by an x. But this is just saying don't change the x is what that means. Okay? So we subtract the two functions, don't change the x, just keep it the way it was, then multiply it by negative 4. And this would be the answer to that one. All right, now this one, that's where we go back up here. So g open dot f of 3 means this. So it's going to be g of f of 3 is what that means. So this would be saying to plug 3 into the f function. So we're going to go to the f function, we're going to plug in 3. What do we get, everyone? 15. And now, so this answer right here is 15. And so now we plug the 15 into the g function. And what do we get? 17 would be the answer to that. All right, you guys try this one now on your own. Number 4. Taylor, do you have it? No. Anybody have it? Tori?
0.
Is it 0? Anyone else get 0? Yeah, it's 0, isn't it? Look, guys, we plug negative 2 into our g function, so negative 2 plus 2 is 0. So this answer is just 0. Now we have to do f of 0. So into our f function, wherever we have an x, we have to plug in 0. 0 times 5 is 0. Okay? All right, this is more difficult. This is saying we're not multiplying. See, look back here. This one is multiplication. This is saying to multiply the two functions. This is saying to take f of x and plug it into g. All right? So we're going to have to do g of, what is f of x? Look back. It's 5x. So this is saying that f of x is 5x. In the g function, wherever you have an x, in the g function, wherever you have an x, replace it with 5x. So I go back to my g function. Here's an x. So g of 5x, here's an x, is going to equal 5x plus 2. So it's all these different notations that look very similar but are done differently. What about number 6? Is that the same thing as number 3? It's not. What's this mean, guys? This symbol. Multiplication. So I'm going to take my g function and I have to multiply it by the f function. And then I just have to simplify. And so when I multiply this out, I'm going to get 5x squared plus 10x. Okay? All right, so those are the basic things there. All right, let's look over here. So this is saying to find f plus g of x and f minus g of x, and then state the domain. All right, so let's first do f plus g of x. We're going to do f plus g on this one. So I'm going to look at these two functions. Are they like terms? Well, this is a cube root and this is a cube root. So if I have negative 1/2 of these plus 9/2 of these, it's going to give me 8/2 cube root x. That's what I get when I do f plus g of x. And now I'm going to just simplify that down to 4 cube root of x. And then I'm supposed to plug in negative 1,000. So it's going to be 4 times the cube root of negative 1,000. What is the cube root of negative 1,000? Negative 10 times 4 is going to give me negative 40 is the answer to that. So again, what I did is I did f plus g. I just added the two functions, and then I just had to plug in negative 1,000 for x. Next thing it says is to state the domain. If I have cube root functions, are there any restrictions on the domain for cube roots? No, we're allowed to have negatives under the radical. So the domain is going to be negative infinity to infinity. That's the way we would write it if we were doing it in interval notation. If you use big ideas, I'm not positive how they'll write it. They may write it as x is an element of the real numbers, or they may just have you write all real numbers. You're just going to have to see which way they want that written when you start the homework. This is a new kind of look to this, but this is just saying x is any element of the real numbers. It's just a fancy way of saying all real numbers for the domain. All right, we're not going to do the subtraction. It's the same kind of concept. We'll do subtraction on this one. All right, so we're supposed to do f minus g of x. So first I'm going to subtract these two. So I have 5 times the 4th root of x minus negative 3 4th root of x. Oops, I missed that. Sorry, let me start again. 5 4th root of x plus 1 minus negative 3 4th root of x minus 2. That's what our problem is. So if I have 5 of these minus negative 3 of these, that's going to give me 8 4th root of x. And then if I have 1 minus negative 2, that's going to give me plus 3. So that's what I'm going to get when I subtract those two functions. And now I just have to plug in the number 1. Here's the notation I would use. F minus g of 1 equals, plug in 1 now, 4th root of 1 is 1 times 8 is 8 plus 3 is 11. All right, what about the domain? Look at the root. Look what we started with. Are there numbers that we cannot use? What are they? Can't use any what? Negatives, right? So our domain then is going to have to be from 0 to infinity. That's our interval notation. If we're writing it as an inequality, x greater than or equal to 0. All right, we're just going to do a couple of these. We're just going to do f, g, x. That means multiplication. We're just going to do that on number 6. So we're going to do 12x times 11x to the 1/2. We're multiplying those. We're going to get that answer. So that's going to be 132x to the, what do we do, guys? When our bases are alike, what do we do with the exponents? Add them, so to the 3/2. Now we have to plug in 4. So we have to do the square root of 4 is 2. 2 to the 3rd is 8. Anybody have a calculator? 132 times 8. What is that? 16. Carry your ones. 5. 1056. So that's what our final answer is going to be when we plug in 4. What about restrictions on the domain? So this function has no restrictions, but what's the restriction here? Has to be what? Has to be positive. So therefore, we can say x must be greater than or equal to 0, or 0 to infinity. Okay? Let's do just one more. Let's do number 8. We're just going to do the division. We're going to do f divided by g of x. So here's f. Here's g. What do we do when we're dividing? Well, we just do 36 divided by 4 for one thing. But what do we do when these bases are alike? What do we do with the exponents? Subtract. So this is going to be 2/4. So subtracting those, we're going to get 5/4, x to the 5/4. So that's our answer to this part. But then we are supposed to plug in the 16. What's the 4th root of 16? What's 2 to the 5th? 32, and then 32 times 9, 288. Now, to find the domain, we must look at the original. We can't look at the end. We need to look at the original function right here. Based off of this, all we'd have to say is that it has to be greater than or equal to 0. But when we look back at this, is x allowed to be 0? Are we allowed to divide by 0? No. So therefore, the domain should be x greater than 0 or 0 to infinity. Because we cannot allow x to equal 0 because of what happens right here. So that you can see why that's kind of tricky. Can you see why people would miss that domain and think they would put x greater than or equal to because of the result? But you got to look back there. Okay, let's see. Let's just look at this real quick here. Which graph represents f plus g? If we add these two together, if we add f and g, what would we get then, Kat, if I add those two? Add those two functions. Good. And so then could we look down here and figure out which one of those is x squared minus 1? Obviously, it says right there. So this one would be f plus g. All right. And then just looking at this one real quick, it says the variable represents the number of pages, the variable x represents the number of pages of a textbook to be printed. The cost C to print the textbook can be modeled by this equation. The selling price P of the textbook can be modeled by this equation. Find P minus C of x. That just means I need to start with P and then subtract the C. The biggest problem people have on this is that they forget to distribute the negative. You've got to distribute that through. In fact, a lot of times I just make it plus and then I change both signs right now so that we don't forget. So when we subtract these, 0.05 minus 0.2, that's negative 0.15x squared. 20 minus 10 is 10. So that's what we get on that. And now it says, what would P minus C of x represent? You guys know? If this is our price, our selling price, and this is our cost, what would our price minus our cost end up giving us? Yeah. It is. Good job. That is called our profit. Okay? All right. That's it. So basically, the big thing there is domain. The domain is going to be everything unless we have that even root or if we have a fraction. If we have a fraction, that denominator cannot equal 0.